Welcome to Daily AI Brief, your daily digest of the cutting edge innovations in artificial intelligence. Today, we explore groundbreaking technologies from Hypernetworks that adapt LLMs instantly to NVIDIA's new tools optimizing GPU utilization. Stay tuned as we dive into examples, trade offs, and practical implementations that shape how AI is transforming our world. Let's kick off with Sakana AI's recently unveiled innovations, Doc-to-LoRA and text-to-LoRA. These methods mark a breakthrough in adapting large language models, LLMs, by generating adapters that internalize new content with a single pass, bypassing traditional retraining hurdles. At the core of these advancements are hypernetworks, innovative architectures that produce low-rank adaptation, LoRA, adapters. LoRA technology works by injecting low-rank matrices into specific layers of an LLM, enabling quick adaptation to new information without sacrificing performance. This method is particularly advantageous because it reduces the need for traditionally computationally expensive training methods, allowing more flexible and immediate model customization. Doc-to-LoRA processes entire documents directly, enabling LLMs to ingest and synthesize information without backpropagation, thus enhancing models' contextual understanding. This capability allows the system to surpass standard context window limits by 4 times, making it especially beneficial for tasks requiring comprehension of extensive documents, such as legal, academic, or technical materials. Meanwhile, text-to-LoRA crafts task-specific weights from natural language tasks, facilitating agile development. It synthesizes LoRA adapters from text-based task descriptions, showcasing significant efficacy in competitive benchmarks with reported accuracies of 76.6% on the ArcEasy dataset and 89.9% on the BoolQ dataset. These metrics highlight the method's robust task performance, achieved without the need for extensive fine-tuning or retraining processes. This capability is particularly useful for developers seeking cost-effective, rapid adaptation solutions. The implications are substantial, particularly in computational efficiency. Traditional model training can be incredibly resource-intensive, requiring significant time and power. By contrast, these hypernetwork methods facilitate on-the-fly usability, offering considerable reductions in computational demands, translating to time and cost savings. Such efficiency not only broadens the accessibility of advanced machine learning capabilities, but also incentivizes agile development cycles, making LLM deployment viable even for devices with constrained resources. However, there are limitations to consider. While promising, the scalability of these methods to larger, more complex models remains uncertain. Furthermore, their generalizability across diverse real-world tasks still needs thorough validation. For those keen on exploring deeper, Sakana AI provides resources at their Doc-to-LoRA page, https://pub sakana.ai/docum source OpenAI. And Emergent Mind offers insights on t2l.emergentmind.com/papers/2506.06105. These platforms offer practical examples and documentation for integrating hypernetworks into workflow processes, allowing individuals to see firsthand how these innovations can be applied to reduce time to deployment and optimize resource use. In summary, Sakana AI's hypernetworks represent a new frontier in making LLM capabilities more efficient and adaptable. By minimizing adaptation times and costs, they pave the way for broader application and innovation across fields that rely on rapid model deployment and customization. In this segment, we dive into Lightrun's groundbreaking AI-powered site reliability engineering (SRE) tool, designed to tackle software errors in real time using cutting-edge artificial intelligence techniques. This development represents a significant evolution from the traditional reactive approaches to a more forward-thinking proactive strategy, fundamentally enhancing software reliability and performance. Lightrun's innovative tool exploits live, inline runtime context, a technique whereby the software dynamically creates the missing evidence required for effective troubleshooting, without the need for code redeployment. By validating root causes instantly with live execution data, this enables developers to engage in real-time debugging and solution testing within production environments. AI agents underpin these capabilities by detecting issues and generating necessary diagnostic evidence, integrating smoothly with existing debugging frameworks to complement developers' workflows. To understand the magnitude of this technology, consider the potential reduction in mean time to recovery, MTTR, a critical metric for system uptime. Lightrun asserts that its AI SRE tool can shrink MTTR from several hours to potentially under 30 minutes. This claim is underpinned by substantial financial support, with $110 million raised in funding, including a significant $70 million in Series B financing, signaling strong confidence in its potential to transform software reliability engineering. However, the transition to such advanced technology isn't without hurdles. The efficacy of the AI SRE tool across various real-world environments is still to be comprehensively evaluated. Companies might encounter resistance within their communities as stakeholders adjust from deeply entrenched debugging practices. The success of the AI SRE also relies heavily on its compatibility with existing systems, which can be a considerable technological feat depending on the complexity and diversity of enterprise environments. For professionals eager to experience these innovations firsthand, Lightrun offers a platform that provides insights and tools vital for understanding and implementing the AI SRE. Their lightrun.com/platform/architecture offers a comprehensive overview of how these tools can be integrated into current systems to improve performance. Additionally, examining lightrun.com/resources, how automation anywheres -SRE, team mastered fast issue resolution with Lightrun/ UTM source OpenEye provides practical examples of how automation and AI are currently mastering rapid issue resolution in real-world scenarios. As the demand for robust software reliability tools grows, Lightrun's AI SRE offers a glimpse into a future where software efficiency and reliability are seamlessly intertwined. This technology not only enhances existing processes, but sets new benchmarks for how system reliability is approached, showcasing a future where proactive engineering strategies lead the way. Google AI has significantly advanced image synthesis with the release of Nano-Banana 2. This state-of-the-art AI model under Google's Gemini suite provides sub-500 millisecond image generation at up to 4K resolution, emphasizing both speed and quality. Designed to function efficiently on mid-range mobile devices, Nano-Banana 2 opens new avenues for developers and users who require rapid image creation. The model leverages advanced neural networks to sustain characters and object consistency across different image resolutions, ranging from a basic 512 pixels to a full 4K. This broad range is crucial for various applications, from everyday mobile use to professional-grade image creation. Furthermore, the ability to support multiple aspect ratios enhances its flexibility, accommodating the diverse needs of content creators across industries. One of the core strengths of Nano-Banana 2 is its approach to subject and object fidelity. The model maintains consistent character depiction for up to 5 characters and fidelity for up to 14 objects. Through this capability, users can produce complex scenes without sacrificing detail. The integration of feedback loops further improves fidelity by iteratively refining the outputs over multiple generations, ensuring that even the most detailed requirements are met efficiently. Nano-Banana 2 delivers these advancements while maintaining a rapid response time. The sub-500 millisecond latency for image synthesis ensures that users experience minimal delays, allowing for near-instantaneous content creation, which is vital for marketing and branding sectors that rely heavily on visual media. This improvement places it on a par with its predecessor, the Nano-Banana Pro, while pushing the limits of what is possible in mobile AI applications. Despite its impressive capabilities, there are a few caveats to consider. Performance may vary across different hardware and operational conditions. Lower-end devices may struggle to execute the model at full potential, particularly when dealing with cloud-based features that necessitate stable and fast internet connections. Furthermore, while the model integrates seamlessly with the Gemini app, its compatibility with other existing Google tools and services remains to be fully detailed. For practical exploration, developers and businesses can access the model through the Gemini app. They are encouraged to experiment with generating images using various aspect ratios and to test the model's abilities with scenes involving multiple characters and objects. Moreover, Developers can find valuable support and insights into model optimization by engaging in the Nano-Banana Developers Forum /nanobanana.ai/community. In essence, Google's Nano-Banana 2 marks a transformative step in image synthesis technology, delivering a tool where speed and quality are interwoven. It provides an innovative platform for developers aiming to create visually stunning and rapid content, thus setting new standards for future AI-driven visual applications. Microsoft Research has introduced CORPGEN, a groundbreaking framework designed to enhance the capabilities of autonomous AI agents performing complex, multi-horizon tasks. CORPGEN addresses essential real-world challenges by streamlining the execution of up to 45 interleaved tasks, each requiring between 500 to 1,500 steps. To tackle these challenges, CORPGEN leverages hierarchical planning, sub-agent isolation, and tiered memory. Hierarchical planning is a crucial aspect as it breaks down extensive tasks into more manageable subtasks. This allows AI agents to focus on immediate goals without losing sight of the overall task structure, effectively navigating large task sets. Sub-agent isolation is another innovative feature, reducing memory interference which often plagues conventional AI frameworks, thus ensuring that specific tasks don't disrupt the performance of others. Meanwhile, tiered memory significantly enhances information retrieval and management by organizing data hierarchically, ensuring that agents access relevant information swiftly and accurately. Furthermore, CORPGEN incorporates adaptive summarization, which selectively prioritizes task-relevant information, thereby reducing the cognitive load on AI systems. This adaptive mechanism ensures that the most pertinent data is accessible to the agents, streamlining decision-making processes and improving overall performance. The framework's effectiveness is evident in its performance metrics. In comparison to traditional approaches, which show a task completion rate of merely 4.3%, CORPGEN achieves a remarkable 15.2% completion rate. This represents a productivity enhancement of up to 3.5 times over existing methods, underscoring the framework's potential to transform corporate environments. Despite these advances, challenges persist. Implementing CORPGEN in highly dynamic real-world environments requires further exploration. Scalability remains a key concern, especially regarding generalizing the architecture across various industries and applications. Additionally, as the system complexity increases, so do the resource demands, which could impact the computational efficiency in real-time operations. For those interested in exploring CORPGEN further, Microsoft Research provides comprehensive resources. Visit the official project page www.microsoft.com/enus/publication CORPGEN Simulating Corporate Environments with Autonomous Digital Employees in Multi-Horizon Task Environments, source = OpenA, to delve deeper into implementation strategies and technical specifics. As CORPGEN evolves, it stands poised to revolutionize how AI agents operate in multitasking environments, offering a robust framework for developing smarter, more capable autonomous systems. This innovation not only boosts efficiency, but could also redefine benchmarks for performance in AI multitasking, paving the way for advanced applications in a wide array of sectors. Perplexity's latest release, the pplx-embed models, marks a significant advancement in the domain of bidirectional embedding models tailored for web-scale retrieval tasks. At their core, these models leverage the robust Qwen 3 architecture, catering specifically to the needs of multilingual retrieval applications. The suite consists of two distinct versions: pplx-embed v1 for handling query inputs, and pplx-embed context v1, designed for processing document chunks. This separation allows for optimized handling of both queries and their respective document matches, utilizing sophisticated bidirectional attention coupled with diffusion-based pre-training techniques. These innovations help in effectively filtering and extracting semantic content, making them ideal for integration into retrieval augmented generation RAG applications. One of the standout features of the pplx-embed models is their significant efficiency in storage and deployment. The models are offered in native INT8 and binary quantization formats, achieving storage reductions of 4x and 32x respectively compared to traditional FP32 formats. Such drastic reductions enable organizations to manage and deploy these models across vast datasets without compromising their computational budgets, thus enhancing scalability. Despite these advancements, certain challenges and uncertainties remain. While the models perform commendably on metrics such as MTB, specific competitive benchmarks, particularly against models like Qwen3 embedding and Gemini embedding, are not detailed. Furthermore, the claimed benefits in retrieval speed attributed to bidirectional attention are yet to be quantified in real-world scenarios. Another area warranting exploration is the model's adaptability to various domain-specific contexts. As web data continues to diversify, maintaining high retrieval efficacy across different fields becomes crucial to the model's success. Yet the implications of diffusion-based pre-training on real-world accuracy and efficiency are still unfolding. For those interested in delving deeper into the mechanics of these models, Perplexity provides comprehensive resources. Their official documentation, h/docs.perplexity.ai/docs embeddings, contextualized embeddings, UTM source OpenAI, offers insights into contextualized embeddings, while Hugging Face, huggingface.co/pplx-embed context v1.6b.utm source OpenAI hosts model variants available for experimentation. Ultimately, the pplx-embed models signify a potential paradigm shift in web-scale retrieval, promising enhanced operational efficiencies for large-scale data handlers and setting new industry standards for multilingual search capabilities. However, as these technologies are tested and refined, Perplexity must ensure adaptability and verify its models' real-world performance to fully capitalize on their innovative potential. On February 16, 2026, Alibaba's Qwen team unveiled the Qwen 3.5-397B A7B model, an advanced vision language model, VLM, designed for building native multimodal agents capable of sophisticated user interactions. As the latest in the Qwen series, this model boasts a massive 397 billion parameters, allowing it to set a new standard in performance and efficiency. The Qwen 3.5 employs a cutting-edge hybrid linear attention mechanism combined with a sparse mixture of experts, MoE architecture. This combination not only amplifies its computational efficiency, but also allows the model to manage computational resources more effectively. MoE leverages a selective activation of its parameters, 17 billion per token, ensuring that only the necessary components are engaged during tasks, which significantly reduces unnecessary processing. Another remarkable aspect of Qwen 3.5 is its integration with NVIDIA GPU-accelerated endpoints. These endpoints enhance the model's ability to deliver randomized yet contextually coherent outputs almost instantaneously. This results in decoding throughputs that are 8.6 to 19 times faster than its predecessor, Qwen 3 Max. This speed is crucial for real-time applications where quick inference can dramatically enhance user experience. In terms of practical implications, Qwen 3.5 translates to substantial cost savings, reducing operational expenses by up to 60% compared to its rivals like GPT 5.2 and Claude Opus 4.5. Moreover, Qwen 3.5 outperforms these competitors on 80% of standardized benchmarks, making it a formidable choice for developers seeking high efficiency at reduced costs. With support for 201 languages, Qwen 3.5 broadens its applicability across diverse linguistic contexts, making it an inclusive solution for global applications. The expansive 1 million token context capacity further extends its utility, allowing developers to build more comprehensive and detailed applications. However, the reliance on the NVIDIA infrastructure means that accessibility could be a challenge for some developers, particularly those without access to high-end GPU resources. The complexity linked to managing a sparse MoE system might also require a steep learning curve for optimally configuring and running the model. Additionally, while the Qwen 3.5 champions excellent benchmarks in controlled environments, real-world performance and deployment nuances are yet to be thoroughly validated. For developers interested in leveraging Qwen 3.5's capabilities, exploring the NVIDIA's official guide, developernvidia.com/blog/develop native multimodal agents with Qwen 3.5 VLM using NVIDIA GPU-accelerated endpoints is a good start. This comprehensive documentation provides insights into setting up, testing, and optimizing applications using Qwen 3.5. In conclusion, Alibaba's Qwen 3.5 represents a pivotal moment for AI development, particularly in integrating multimodal processing. which combines visual and linguistic inputs in innovative ways. It sets a promising precedent for future advancements, pushing the boundaries of what AI can achieve in enhancing interactive, user-centered technologies. As multimodal AI becomes more entrenched across industries, Qwen 3.5 stands at the forefront of this exciting evolution. NVIDIA has recently unveiled a transformative approach to GPU management within AI infrastructures, launching tools designed to maximize utilization through dynamic resource allocation. At the forefront are NVIDIA Run AI and NVIDIA Inference Microservices, NIM, which collectively aim to redefine how GPUs handle fluctuating workloads by leveraging dynamic GPU fractions. Dynamic GPU allocation. Traditionally, GPUs were constrained by static memory allocations, often resulting in significant underutilization during periods of low demand. NVIDIA's introduction of dynamic GPU fractions within Run AI changes this narrative significantly. By allowing memory allocation to adjust in real time based on workload demands, these tools ensure that GPU resources are utilized more effectively, thereby optimizing performance and achieving better cost efficiency. Interestingly, NVIDIA's dynamic memory allocation has shown promising results. Benchmarks indicate throughput improvements of up to 1.4 times and latency reductions by 1.7 times compared to static allocation methods. This translates to not only cost savings through enhanced efficiency, but also improvements in application responsiveness, a critical factor for businesses relying on large-scale AI models. Integration and monitoring. The deployment of these tools is facilitated by seamless integration with existing Kubernetes infrastructures, which are prevalent in modern cloud environments. The system's flexibility hinges on its robust API integrations, providing developers with visibility into resource utilization metrics crucial for maintaining optimal performance levels across distributed systems. Such enhanced observability is vital for organizations aiming to dynamically balance loads without compromising scalability or operational speed. Practical implementation. Organizations keen on implementing these tools can refer to resources such as the NVIDIA developer blog, developer.nvidia.com/blog, maximizing GPU utilization with NVIDIA RunAI, NVIDIA NIM/UTM source OpenAI, and the detailed NIM microservices documentation. www.nvidia.com/ES AI Data Science Products NIN microsource open. These resources provide insights into testing dynamic GPU fractions within Kubernetes environments and address integration challenges. Developers can experiment with these innovations to effectively manage variable demand applications, minimizing manual intervention and fine-tuning GPU workloads dynamically. Challenges and limitations. However, scaling these innovations isn't without its challenges. Existing systems, primarily tuned for static allocations, might face compatibility issues. Performance can exhibit variability depending on workload configurations, necessitating long-term evaluations to ensure sustained benefit realizations across different application scales. Strategic implications. NVIDIA's advancements signify a strategic shift in AI workload management. This approach not only boosts performance, but also potentially lowers barriers for deploying complex AI systems by making resource management more intuitive and adaptive. For organizations, this could mean a drastic reduction in overall AI operating costs and a notable increase in operational efficiency. As the industry responds to this shift, NVIDIA's role is pivotal, likely catalyzing further innovation in resource allocation technologies. The ongoing evolution through continuous updates with the latest inference engines could establish NVIDIA's solutions as indispensable to businesses striving for GPU efficiency within AI workflows. That's it for today's episode of Daily AI Brief. We've explored how innovations like hypernetworks, dynamic GPU tools, and multimodal models are shaping the future of AI. Join us tomorrow for more insights into the technologies revolutionizing our world. Until then, keep innovating.